All right, so we're picking up where we left off in section 4.6. And in this example 4 here, it says to find the complex zeros of the polynomial. All right, so eventually we're going to write this polynomial in factored form after finding the zeros. So we have to put together what we did in section 5 and section 6 together. So we're going to think back in terms of how to find the roots using the sign rules and the P's and Q's and all of our factoring here. So first thing I want to do is I'm going to first say I have a 4th degree polynomial. So this is degree 4. So that means I'm going to end up with 4 roots. Okay. And what I want to do is find all the zeros. And that would be real numbers and imaginary numbers. So I'm going to find real numbers and imaginary numbers. So first thing I want to do is I want to know about my roots in the signs. So I'm going to use the sign rule and find the sign changes. So for f of x, okay, which is basically this, I start off with a positive leading coefficient, and I go positive, positive, no sign changes here, and I don't have a sign change until the end. So here's 1 sign changes, and that tells me I'm going to have 1 positive root. So one of my roots is going to be positive. So if I find f of negative x, this is going to tell me how many negative roots I'm going to have. So if I plug in negative x into this function, remember I change the signs when I have an odd exponent. So instead of writing all of this, I'm going to have a negative here. I'm going to start off positive. And this is going to be negative because of the odd exponent. This is going to stay positive. An odd exponent here, so this would be a minus 45x, and then the minus 18 stays the same. So now if I look at my sign changes, I have positive to negative, so here's 1. A negative to positive, here's another one. Positive to negative, here's another one, and then negative, negative. So this tells me I'm going to have 3, so f of negative x is 3 sign changes. So I'm going to have 3 or 1 negative roots. So 1 has to be positive, 3 could be negative, or 1 could be negative. Now, if 1 is negative, that means I would have 2 more roots that are imaginary. All right, so this just gives me some possibilities. So now if I look at my coefficients, so I'm going to look at my P's and my Q's. And the P is 18. And my Q is 3. So if I write all of my factors of 18, I have 1, 2, 3, not 4, not 5, 6, 9, and 18. Those are all the factors of 18. Now remember, these could be positive or negative here. Positive or negative. I have to have 1 positive for sure and one negative for sure, but I could have 3 negatives. So then on the bottom here, I have 3, and the factors of 3 are 1 and 3. So my possible roots are all of these numbers divided by 1. So I can have plus and minus 1, 2, 3, 6, 9, 18. Now I need to take all of these numbers and divide them by 3. So 1/3 could be a possible root. 2/3 could be a possible root. 3/3 is 1. 6/3 is 2. 9/3 is 3. And 18/3 is 6. So the rest of these bigger ones, when I divide by 3, I get whole numbers or integers. So I only have 2 fractions here. So technically this is 1, 2, 3, 4, 5, 6, 7, 8 roots, positive and negative. So there's 16 possible roots that I can have. All right, so this is really a lot of trial and error. And where do we start? So let's start with a negative, and let's start with -1. And usually I like to start off with the smaller numbers first. So if I start with -1, and my coefficients are 3, 5, 25, 45, and -18. All right, so 3, 5, 25, 45, -18. So let's just start and see if -1 works. All right, so bring down my 3. This would be -3. Add down, I get 2. This is -2. This is 23. This is -23. Add down, I get 22. -1 times -20, or -1 times 22 is -22. So this gives me -40. So I know that -1 doesn't work. All right, how about -2? Okay, again, trial and error. So let's do this. -2, same coefficients, 3, 5, 25, 45, and -18. I'm going to bring down my 3. -2 times 3 is -6. Add, I get -1. -2 times -1 is +2. I get 27. -2 times 27 is -54. Add down, I get -9. Ooh, this looks good. -2 times -9, +18. And I get remainder 0. Woohoo! So I know that x equals -2, and I'm going to write this down here, is a root. So now I'm left with, I'm going to kind of separate this. I'm left with a polynomial that is 1 less than what I started. So I have an x to the 3rd power. So this would be 3x to the 3rd minus 1x squared plus 27x minus 9. So this is my polynomial that I have after I divide by x plus 2, because x plus 2 would be that factor. So I'm going to try now another possible root. My coefficients are 3, -1, 27, and -9. Now, one thing I know about this is that these numbers, 3, 27, and 9, these are all multiples of 3. So I need a positive number because I have my negative root. So let's try 1/3. Okay, so let's try 1/3 as my 0. And I just see that there's multiples of 3, and that's why I did that. Maybe it's 2/3. I'm going to start with 1/3, bring down the 3. A third of 3 is 1. 1 plus -1 is 0. A third times 0 is 0. Bring down 27. A third of 27 is +9. And I get remainder 0. So I know that x can also equal 1/3. All right, now we're getting somewhere. Now what I have left, this would be 1 less than my exponent here. So this is 3x squared plus 27 is my polynomial. If I set this equal to 0 and try to find the roots here, I could divide everything by 3. And this would actually be x squared plus 9 equals 0. And if I subtract 9, x squared is -9, square root both sides, and x equals plus and minus 3i. So these are also roots, and this is my conjugate pair. All right, so I have a root of x equals 3i and x equals -3i. And if I were to write all of the factors, I'm running out of room to do that. I'll write them right above here. So this would be x minus -2, so this would be x plus 2. This would be x minus 1/3. This would be x minus 3i. And this would be x plus 3i. And there's my 4 factors that would multiply together to get this 4th degree polynomial. All right. So let's do one more example. So here I'm looking for the complex zeros of the polynomial function. So I am going to have 4 roots because my degree is 4. All right, let's see what kind of roots I'm going to have. So I'm going to do my sign changes. And for my sign changes, I have a plus, 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 minus. So I have 1 sign changes. So that means I'm going to have 1 positive root. Now let's look at f of -x. And I'm going to go back here. So for -x, if I plug this in, even function stays the same. Odd exponent will change the sign. Even exponent, sign stays the same. Odd exponent will change the sign. So if I'm looking for sign changes, I go from positive to negative, negative to positive, positive to negative. So for my negative roots, I can have 3 or 1 negative root. Okay. So now let's look at what the possible rational roots are. So this is where I'm looking at my p's and my q's. My p is 75 and my q is 1. I like when it's a 1. So 75, the factors are 1 and 75, not 2. 3 goes into this because 5 plus 7 is 12. 3 goes into 12. 3 goes into 75 25 times. 4 does not. 5 will go into 75 15 times. Not 6, not 7, not 8, not 9, and not 10. Usually if you go up to 10, you're covered. So these are my roots. They're all going to be divided by 1. Okay, so I have positive and negative, and these are my possible roots. All right, so I know I have 1 positive and 1 negative. So let's just start with 1. This time I'll start positive. And my coefficients are 1, 2, 22, 50, and negative 75. Bring down 1. 1 times 1 is 1. And then I add down, I get 3. 1 times 3 is 3. Add down, I get 25. 1 times 25 is 25. Add down, I get 75. This is looking good. So this is 75, and then I get remainder 0. Okay, so I know that x equals 1 is one of my factors. That's my positive one. Now I need to find a negative factor. All right, so these now are my coefficients. This is 1, x to the third, 3x squared, 25x, and 75. Okay, so I'll write that out. That's a cubed, 3x squared, 25x plus 75. So if I multiplied all of this times x minus 1, I get back to my original. All right, so now I'm trying to find my negative number. So let's start here with 1, 3, 25, 75. And negative numbers, let's try negative 1. So bring down 1, this is negative 1, bring it down, I get 2, this is negative 2, add down, I get 23, this isn't going to work. 1 times 23 is negative 23, so doesn't matter. Negative 1 doesn't work. Let's try negative 3. So I have the same numbers, 1, 3, 25, and 75. Bring down a 1. This is negative 3. This is 0. This is 0. Add down, I get 25. Negative 3 times 25 is negative 75, and remainder 0. So I know that my other, or my negative factor, is negative 3. And let's look to see what I have left. This would be x squared plus 25. So I'm not able to factor the sum of squares and get real number roots. So I can subtract 25 on both sides and square root both sides, and x is going to equal plus and minus 5i. So those are my other roots. And taking these 4 roots, I can now write my factors. So I am going to have x minus 1 is a factor, x plus 3 is a factor, x minus 5i, and x plus 5i. And these are my 4 factors that give me this polynomial. So from what we've gone over, this is what you should get out of this. So complex roots. If I have imaginary numbers, they come in pairs. So I have conjugate pairs. Fundamental theorem of algebra. Means that you can factor anything. Into complex roots. Another thing, and maybe we can point this out, is if I have the sum of two perfect squares. And oh, that was bad. S-Q-U-A-R-E-S. So the sum of two perfect squares, like x squared plus any number squared, this can be broken down into x plus ai times x minus ai. Okay, so I can factor these into imaginary or complex conjugate pairs. Okay, but if I were looking at the sum of two perfect squares, remember we can't break apart the sum. So if I'm looking for real numbers, I can't do that. But because of the fundamental theorem of algebra, I can factor anything. I just don't have to have just real numbers though. And to find complex roots, use the rational roots theorem. Okay, the rational roots, we think of a rational, and this is the P's and the Q's. And that's going to help us find the rational roots. All right, so here we are. That is everything for this section, and we should be getting ready for a test coming up. Okay, so we've covered everything.